Hello, everyone. Today we are going to look at a few examples in which we have multi-step equations in fractional form, as well as multi-step equations that have fractions in them. In both situations, we're just going to be removing the fractions from the equation to make it much easier to solve. So let's begin with example 1. The first step in example 1 is going to be to remove a grouping symbol. We normally start with undoing addition or subtraction as our first step, but because that fraction bar is a grouping symbol, this fraction bar right here, it kind of puts everything in the numerator and everything in the denominator in jail until we get rid of it. That's how I think of it. That's a silly way to say it. So the fraction bar means division. We know the opposite operation is to multiply, and when we're undoing division or multiplication, we always use the exact same number that's already there. So I'm going to multiply by that positive 2 on both sides. As a result, the division by 2 is all gone. That removed our fraction bar. And the new equation would be 2 times negative 2 over here on the left gives me negative 4 equals, and the only thing remaining is what was in the numerator, the 3x plus 5. Now it's a very simple two-step equation solving process. If you like the variable on the left side, of course, you're always welcome to flip-flop the sides of this equation. I'm going to go ahead and leave it this way. The next thing I undo is addition or subtraction, and we have the addition of 5. So the opposite of that is to subtract 5. That's what I'm doing to both sides. Negative 4 and negative 5, when I put those together, I get negative 9. You can do that on the calculator as negative 4 take away 5. The plus 5 is canceled out, and I just have my 3 times x remaining. To undo that multiplying by 3, we will divide by the same positive 3 that is there. And that removed the 3. I now have negative 3 equals x as my final answer. Okay, I'm not going to walk through the entire thing with another example, but I just want to continue to emphasize when we see this original situation where we have an expression over a number, pretty easy to cancel out that fraction bar and the denominator so that life is much easier. Let's just write another example very quickly. I think we'll do 5 equals 2x plus 4 over negative 2. So this time we are dividing by negative 2. Still need to just remove the fraction bar as our starting point since it's our grouping symbol. And so this time I'm multiplying by negative 2. Always multiply by whatever number is in the denominator when undoing division. So this negative 2 and the fraction bar are all gone. The negative 2 times 5, sorry, this is a multiplication sign. The negative 2 times 5 leaves me with negative 10. And on the other side, I just have my 2x plus 4. So now it's a regular two-step equation, which I will leave for you guys to solve. Okay, so that was example 1. Let's move on to the next example, which is about clearing fractions from an equation. In this example, all of the numbers in the denominator are the same, which makes it quite easy to clear the fractions out. Even though this fraction says 1/3, we know that this part of the fraction really means divided by 3. So if I want to undo it, I can just multiply everything by 3. So what that really means is I'm going to multiply the entire equation, since I need to do both sides multiplied by 3, and that will remove every fraction from this equation. If I just write this out really clearly, I'm doing 3 times the 1/3 x, and then I'm doing 3 times that 2, equals 3 times the 2/3. Well, here we have canceled out the division with multiplying by 3, and the same thing has occurred here. Now we just need to write everything that remains. For the sake of this example, I'm going to go ahead and write that we have a 1x remaining here. We don't typically write coefficients of 1, but there's nothing wrong with doing that. The 3 times 2 gives me -6, and that's equal to, the only thing remaining on the right side is the number 2. We now have a two-step equation that we can finish solving. I'll solve this one. It's really just a one-step because that coefficient of 1 doesn't need to be written there. So to remove the to remove the subtract 6, I'm going to add 6 on both sides. And the 1x is the exact same thing as just the letter x by itself. So gone, and the 2 plus 6 gives me 8. So my final answer is that x equals 8. All right. Let's just keep going to the next example, example 2b. All right, in this example, we have different denominators. And so in order to get rid of different denominators, we need to find a number that both of those multiply into. So that's what step 1 over here on the right means. This step 1 says find common multiple of denominators. Well, there's a lot of different ways we can do that. Probably one of the easiest is to Google multiplication chart. And then I just automatically have a list of multiples. So when you look at this top row of numbers, the numbers below 4 would all be multiples of 4. 4, 8, 12, 16, and so on. And then I can do the same thing. Look at 6 in the top row. 6, 12, 18, and so on. Well, the smallest number that I see as a multiple of 6 and a multiple of 4 is the number 12. Okay, so that is one way to find the least common multiple. That is what I have as step B right here, not step B, as option B. You can just look at a multiplication chart. Another option is to actually make your own list of multiples. Let's do that just so you understand what I mean by that. We can do the list of multiples of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And I could keep going, but we already discovered from the multiplication chart that 12 is going to be the common multiple. As I start listing multiples of 6, 6 times 1 is 6. Of course, I could have just copied this right off of the multiplication chart. And 6 times 2 is 12. There is a number that both denominators will multiply into. That is the one I'm going to use. It's the smallest one, which keeps our numbers smaller. Now it's the same process as what we just did before, or similar anyway. So you see down there on step 2, it says multiply the entire equation by the number that we found in step 1. So I'm going to go ahead and write that out nice and clear. 12 times the 3/4 x plus 12 times the 5 equals 12 times the 5/6. Okay, so again, multiple ways that we can look at this, but one easy thing to do is realize that I can, since 3 does not divide evenly by 4, I can think about this 12 divided by 4, and what I get from it is 3. Okay, so that just keeps our numbers smaller. What it means, sorry about that, what it means is we're going to replace this 12 divided by 4 that I have in blue with the number 3. Of course, that means the 12 and the divided by 4 are gone, and I have times 3x, that's what else was left there, Right here I have a 3 and an x remaining. Okay, now I see my plus sign. And then the 12 times 5 creates 60 equals, now we're going to do something very similar over here. We have 12 divided by 6 that we can do. And when we do that, we get 2, which means the 12 divided by 6, they're all gone, and the fraction bar is all gone, but they are replaced with 2. And that also left a 5, 2 times 5. All right, we'll pause here. All right, that much. We just have one last step to get to a basic two-step equation, and that's the multiplication. The 3 times 3x gives me 9x plus 60 equals that 2 times 5 is 10. Now it's a very nice two-step equation to solve. I'll leave it there, but to finish solving it, we would undo the addition of plus 60 and then undo the multiplication of 9. All right, so the next one, example 2C. Again, we're clearing fractions, just another example of that. And so this time, I can once again find the common multiple of those denominators. The two denominators are a 3 and a 5. I've got these possible methods. I really like the multiplication chart option. If we go ahead and make a list, though, we'll find out that for this particular one, because they are prime numbers, all we needed to do was multiply the denominators together. The only reason I don't just automatically do C is sometimes that makes a much larger number. Like this previous problem we just did, this problem, if I had done 4 times 6, I would have had 24. I would have been multiplying the whole thing by 24. It just makes bigger numbers, but you can do that. You'll still get the very same answer. You're just going to deal with larger numbers as you solve it. Okay, so if I go ahead and figure out a common denominator, whoops, let's use a different color. So here's 3, and here's 5. I'm making my list of multiples. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5, which is the other number, is 15. So 5 times 1 would have been 5. 5 times 2 is 10. And 5 times 3 is 15. So we see that this is the first number that is common, meaning shared by a multiple that is shared by both 3 and 5. All right, so that means we're multiplying this whole equation by 15. And when I do that, if I write it out, we're doing 15 times each term. So 15 times 3, take away 15 times 2/3 x equals 15 times that 2/5. All right, same process now. The 15 times 3 will leave me with 45. When I go to look at this, remember the 2/3, I can't do 2 divided by 3 and get an even number, but I can do that with 15 divided by 3. And when I do that, 15 divided by 3 will leave me with a 5. So I'm going to go ahead and bring down the subtraction sign. This 15 and divided by 3 are all gone, but they're going to be replaced by that 5. I can't forget that I still have my 2 there, so times that 2 and the x that is there. And then we're going to do the same idea over here. We're going to get rid of this divided by 5. So 15 divided by 5 is what I'm doing. That'll cancel all of that out. 15 divided by 5, of course, is a 3. So in place of the 15 times and the divided by 5 part, I now have a 3 times the 2 that was already there. Let's see if we can separate this part a little bit because they're way too close together to make sense of. All right, so hopefully now you can see a little more clearly what we just did. We got the 45. We canceled out this 15 and divided by 3. Doing 15 divided by 3 gave us the 5 that's right here. Then we had to remember that there was a 2x up there. There it is. This 15 divided by 5 gave me this 3. I had to remember it's being multiplied by the 2. Okay, now we can just do that one last step of multiplication, and we have our 2-step equation. Minus 10x from 5 times 2 equals the 3 times 2 makes it a 6. And now we can solve that equation by undoing addition, subtraction first, and then undoing multiplication after that. All right, so that was 2c.